In this video, I'm going to guide you through some analysis of a polynomial function, and we're going to create what I call a sign chart. I think many instructors probably do, but the idea is to figure out where the polynomial equals 0, where the polynomial is positive, and where the polynomial is negative. So I call that a sign chart. So we're going to work through this. So the instructions for the problem we're going to work is create a sign chart for the function. Okay, create a sign chart for the function. It could also say something like determine whether function is 0, positive, or negative. Okay, and that's useful for lots of things. Usually you don't create a sign chart just to create a sign chart like we're going to do here. Once you've got a sign chart, you can do different things with the function, like graph it, solve an inequality involving the function, various things. Okay, so this is just a tool for us. So the function we're going to work with is f of x equals 2x to the fourth minus 5x to the third minus 3x squared. Okay, and a couple useful things to know when creating a sign chart are end behavior and zeros, and of course with zeros it's nice to know their multiplicities. So this function is simplified, okay, meaning there's nothing left to multiply together. All the like terms have been combined. It's not factored, it's unfactored. Okay, so is there anything useful we can get from a function that's not factored, one that's simplified? The answer is yes. We can get the leading term. Okay, so see if you can identify the leading term of this function and then use that leading term to draw the end behavior of this function. Okay, so pause the video and see if you can figure out those two things, and then come back and check your answers. Okay, so the leading term here is 2x to the fourth, which means the end behavior, both ends go up. Okay, up and to the right, up and to the left. So make sure you understand those two answers. Now if I want to get my zeros, then I need to factor the polynomial. I need to look at the factored form. So that's the next thing you're going to work on, is try to factor this polynomial. It's a trinomial, but before you deal with that, look for a greatest common factor for all three terms and pull that out, and then factor the remaining trinomial. So pause the video, take some time, and see if you can figure out how to factor the polynomial, and then come back and check your answer. Okay, when you factor this, you should get x squared times x minus 3 times 2x plus 1. And the x minus 3 and the 2x plus 1 could be interchanged. The order of those does not matter. Okay? Now what's useful about the factored version is it gives us the zeros. So now what I want you to do is see if you can identify the zeros and multiplicities of the function. Okay? So pause the video, see if you can list those, and then come back and check your answers. Okay, so the zeros are 0 with multiplicity 2, 3 with multiplicity 1, and negative 1/2 with, sorry about that, put my parenthesis in the wrong spot, negative 1/2 with multiplicity 1. Okay, so now we've got all the pieces here. We've got our end behavior, and we've got our zeros and multiplicities. We've got all of our pieces to create our number line chart, our sign chart for this polynomial. Okay, so set up your number line. We'll use a number line for a sign chart, and on the number line we're going to cut it at our x values, our zeros. Remember, zeros are x values. So if you want, you could list these as x equals, x equals, x equals. So cut your number line chart at those three values. Okay, so you're going to have 3 cuts on your number line chart. Then, once you've got that, above your number line chart, go ahead and write in the y values at those x values. See if you can calculate the y values for those x values. The way to do that is, whatever the x values are you have down here, plug them into the simplified version or the factored version. It doesn't matter because they're both the same function. Plug those x values in and see what you get for y, and then put those numbers up here. Okay? So calculate the y values for each of the x values you've got. Then once you do that, in fact, why don't you pause the video and get those answers and come back and check. Okay, so the first x value is -1/2, the next one is 0, and the next one is 3. And the y values for all three of those x values is 0. So then you should have those answers. Now what I want you to do is use your end behavior to go in and describe the y values on the ends of your number line chart. Okay? So pause the video and write those in, and then come back and see if you get those right. You should have a plus and a plus on the ends of your graph for those y values. The next thing I want you to do is use the multiplicities of the three zeros. So that's multiplicity 1, multiplicity 2, multiplicity 1. Use the multiplicities to determine if the sign changes or stays the same across each of those zeros. Come back and check your answers to this. So the first one, the signs should be different, or they should change, whatever word you want to use. The next one, the signs should be the same, and the last, the signs should be different. Okay? The last piece is to go through and fill in the signs of the middle two intervals based on what you have here. So see if you can fill that out and come back and check those answers. You should get a minus and a minus. Okay? So the final answer, the final number line chart, excuse me, or sign chart is this here. So the function is positive from -infinity to -1/2. The function is 0 at -1/2. The function is negative from -1/2 to 0. The function is 0 at 0. The function is negative from 0 to 3. And the function is positive from 3 to infinity. And you can use that to do lots of different things for the function. But if you had trouble with any of this, go back through, listen to the tips I gave throughout the video, or maybe rewatch my video teaching this concept, and then come back and see if you can get this right.